Good morning. And that was Fleetwood Mac, and I'm assuming that was the first cut, secondhand news. And with that, probably the secondhand news this morning is an exam on Thursday, just to remind you again. And we worked yesterday in 8.1 and 8.2. My hope was that you could go through the problems in 8.1 quickly. Did that go well? Got confused in the problems in 8.1. Okay, well, let's talk about what it was. That's, again, the argument being on what we think we can do that should go very easily. And Ernie, we're getting feedback horribly. Are we okay now? But in terms of what you think you can do, you want to check it and see if you have questions. So what kind of question do we have regarding 8.1?
For the decimal point, and then it would say 5.25 over, it was a percent, and you had to pull over 100, and then reduce it?
Okay, so we have a percent. We're changing it to a common fraction.
Yes.
And you had something like 5.25%.
Yes.
Okay? Well, let me first go to the problem on the board. So you have something like this, 5.25%. And you want it to go to a common fraction. Is that correct? So you have two ways of looking at this. One is doing this, but that's not a common fraction because it's a mix of a fraction and a decimal. So if you were to do that, the next thing is multiply the top and the bottom by 100 to get the decimal out of here. So this would then, because you don't want the decimal there, this is one way of doing that. And of course you get a very large denominator because that would be 10,000. Yeah, because you're wanting, the question is how many zeros at the end. But if you're wanting to get rid of this decimal, you have to move it two places to the right. Now this can be reduced. Now a better approach from my perspective is to rewrite the 5.25% is 5.25%. Then rewrite that as 21, over 4 over 100. And then that, when you invert and multiply, because this is over a 1 now, will give you 21 over 400. Now this you cannot reduce, but if you were to reduce this, it should come back to that. So this is a little more direct. That's a good question because we haven't thought too much in terms of trying to go from something with a decimal representation to a common fraction. So yes, that would be one of those glitches that you wouldn't anticipate. Does that answer the question? Okay, is there, okay, Natalie? Okay, but if you did, it was 4.6% though, right? So you have 4.6%. Now, your statement is that you wanted to put it over 10. That's good. That's 46 over 10, but it's still percent at that point. So that would be 46 over 10 over 100 over 1. And then you'd have the 46 over 1,000. And then again, you can reduce that, 23 over 500. However, if you came back up here and said you had 4 3/5, because 6/10 is 3/5, so you could have said, well, that's really 4 3/5%. That's 23 over 5 over 100 over 1, and immediately you can see, I hope, that you get exactly the same thing. And again, what we focused on yesterday was to take decimal representations as common fractions. And that is a little bit further along than what we did in 10, based on the same idea. And so your intuition was good, 46 over 10, but you still had the percent sign. And that's what you have to get rid of. Yesterday's work with those repeating decimals with fractions was something also very new. So in a sense, both of your questions go a bit beyond 10, and that's what makes 20 more interesting. But it's based on the same idea. Anything else in 8.1? So 8-1 we're okay? Richie, a question? Okay. Couldn't read whether it was looking or question. Okay. And in terms of 8-2, where we were translating now to equations and trying to go from there, is there anything with that that you had difficulties on? 8-2. Now, I expected to have 8-1 done, and I was hoping that you had time to look at 8-2. You looked at it, but didn't do very many problems. Okay. Yeah, the ones in the book would be the point in doing those. And again, let's just do one of them to review the process. As I come off here and go back center, try to get this physical desktop so I can get something under the document cam here for a moment. This is 8-2, okay, and in terms of 8-2, we're taking a verbal statement and simply translating it. So, again, just without taking any particular problem more representative than another, let's look at 27, in which I have 605 is 2.5% of what number? So leaving that on the screen for a moment, let me write what we have. So 605 is, then I have 2.5% of what number? And again, that's as a question, but as we go to the board now, the is, we're translating into what? The equal sign, correct? The of, we're translating into multiplication. So we're going to trade this in here for an equal sign, and this for an x for the moment as multiplication. Now, we don't like using the symbol x for multiplication because we want to use that for an unknown, a variable. So I'm going to make that a big dot and use this for x. So to that extent, I'm saying 605 is equal to, and whether you want to write 2.5 over 100, 0.025, 2 1/2 over 100 is a little bit of an option. But this translates to me into this equation as the most direct route. Now, at that point, this is like saying 605 is 25 times x. My point being, this may throw you a little bit because it's a decimal smaller than 1. But if I just had 25x, you'd say, well, I'll divide both sides by 25. So instead, I'll divide both sides by 0.025. And then, x is by itself, correct? And you have to do the division. So if we look at that, and it would have been a lot nicer if that had been a 625, because then we could have handled it much more quickly. But just to remind you, you're going to have to move the decimal over 3 places, and so you're going to have this problem. And now, this is sort of in a messy sort of way. But if you look at it from the standpoint of a division problem, it's not that bad. But just finishing it out, we'd have a 2 here, and that would leave us a 105. And so that's going to be a 4, leaving us a 5, so that'll become a 50, that'll become a 2, and a 00 for 24,200. Just doing short division. And so my x is 24,200. But that's the arithmetic part. That's going back to 10. This part up here, translating from this verbal statement into this equation in one variable, pretty straightforward. Is there any question about that? And all of them fall into this genre. You get an equation, and you solve for the unknown, the variable. Now, I didn't have to use x. I could have used y. I could have used z. Technically, I could have used any letter of the alphabet I want, but we try to use the x, y's, and z's as opposed to the a, b's, and c's. So as a kid, you learned your ABCs. Here you learn your x, y, z's. Kim?
So we're going with 605 and then equals, and then we're going to have 6.5?
Well, I have 0.025 times x. This means when I have nothing between the 0.025 and the x, that means multiply. Just like I had 25x or 5x. The fact that it's a decimal is what messes you up a little bit. And that's what makes the problem harder. Perceptually harder. I don't think it makes it harder. It makes it a little bit tedious doing this division. But as far as appearance, 625 equals 25x. If I just gave you this problem, you would say that's a much easier problem. 25 squared is 625. So 25 into both parts, you'd have this as your solution. And my guess is, just because the numbers are so nice, you'd say that's an easy problem. Compared to what? To this one, which appears to be much more difficult. But they're the same thing. And seeing the common structure between these two problems, and seeing that this problem, which you feel comfortable in doing, okay, is precisely what you're doing with this one, where you're not so comfortable. That's a lot of the battle in algebra. Taking what you do know and then say, I'll do the same thing. Particularly in terms of word problems, where with word problems you have something where you say, well, this word problem is a little bit harder than that one. Well, what would I do if it's easier? What would I do if it was just 25? Well, I divide both sides by 25. Okay. Do what you were going to do. Now, the difficulty is, if the intimidation factor of the problem is such that your mind goes blank, then you may not be in a position to try to recover something from your past. I call this sort of a benchmark for the problem. How do you do an easier version, then do one the same way that's a little more difficult? And in practice, I do this all the time. I get a difficult problem, say, okay, what would I do then if it were easier? Didn't look so rotten. Okay, let me try it doing it the same way and see if it works. And that's what makes, hopefully, the magic happen. You know the question in 8.2. And again, what you have to do is what? Simply spend some time doing it. That's all that has to happen. Okay? I'd like to go into 8.3 unless there is more of a need to spend time in 8.2. No problem. Okay, I'm going to go back center, Ernie, and then I'll go to 8.3 in the document cam here in a moment. Let's see if I have things mixed up here in terms of what I was doing. I do not. 8.2. Okay, 8.2 we just talked about. 8.3 is pretty much more of the same, but with a little different caveat, and that is changing it from a translation of an equation to a proportion. So the idea is probably best stated in this, I guess call it a formula, an equation. Percent equals part over whole. Now that's one of the three that we had. So if I come over here and just think of percent as part over whole, this is out of what we did in Math 10. But the difference here is I'm going to consider R as a percent. So that means I'd have R over 100. Not as a decimal, but just as a percent. So I'd have R over 100 equals part over whole. Well, that's a proportion. So we're back to exactly what we did with our triangle. You just ask which one of these don't you know? And you have a choice. You could say, if it makes it any easier to remember, P over W. So all I do is find out which one I don't know, fill in the others. I have a proportion, cross multiply and solve. That's the essence. Let's go back to the document, Cameron. That's what's done in all these problems, changing them to a proportion. Now I sort of like that as a nice tie-in with what we did in Math 10. Because now you can do what I talked about there, and I talked about it at that time, more as just an alternative we would consider later. Later is now. Okay, the future is now, in a sense. The future then is today's now, which will be Math 70's past. So I don't know if we're going back to the future or forward. I haven't quite decided on that, but let's just look at a problem. Okay, I'm just picking pretty much here at random, but I want to try to keep the numbers halfway decent. The thing that will make some of these a little bit difficult is going to be that they are large values. But I'm looking at number 9 now. This is on page 595. Okay, and Ernie, I am going to go to the sideboard, so if you could free up the camera over there, I'd appreciate it. So number 9 is what number is 15% of 9.5? Now what makes that problem hard? And it's not hard particularly, but makes it harder than the usual run-of-the-mill. The 9.5, correct? So first I'm going to write the problem. What number is 15% of 9.5? Okay, we got the problem on the board. You have a choice. 9.5 can be left the way it is. You can treat it as 9.5, correct? Now, if I think of this as a problem we just did, x equals 0.15 times 9.5, done. That's not a bad way of doing it. If I go to what we just wrote on the board, that r over 100 is equal to p over w, then all I have to do is look at this statement up here, and I think this is a little bit harder to do. I should make that equal sign so it looks better. If I'm taking a percent of something, it's the part I don't know, correct? So this is the one letter I don't have. So to that extent, I have 15 over 100 is equal to p over 9.5. That's just substituting. Got 3 things. I know 2 of them. Substitute the 2 I have and solve for what I don't have. The minute I have it in this form, it's a proportion. Cross multiply. So this becomes p times 100, which I think I'll just write as 100p. And that's equal to 15, and I have to use the parentheses at this point to do this. Then divide both sides by 100. And I have a choice. Do the product and then move the decimal over 2 places. That's probably not a bad way of doing it. Or I can cancel. 5 will go into here, 5 will go into here. I don't gain a whole lot in doing that. So that solution isn't any different than what I'm doing right here. Because the 0.15 is 15 over 100 times the 9.5. You're getting exactly the same answer either way. Any question in that? It's just another way of setting up the problem. Any questions? Well, the 9.5, if I come up here, because I'm taking something times that, when I take a percent times the 9.5 has to be the whole. Now, I could have said, let me rewrite it in a different way, different problem, not the same. But if I said 9.5 is what percent, don't want to say it that way. I'll do it this way. Is 15% of what number? This is a variation. This is a different problem. But now, this is my part. This would be the whole. So I could say that 9.5 is 0.15 times x. Then I divide both sides by 0.15, the 15%. So I'd have this which is your part over percent. And the only thing that makes these two different is where they're located. So to say that 9.5 is a percent times some number means this was the part, the whole I'm missing. As I slide over here, I'm saying I'm taking 15% times something. Whatever I multiply 15% times, this becomes the whole, and this is the part. That's the difficult point. And that brings us right back to Math 10. You had the triangle. What don't you know? So if you don't know the part, you had a formula for it. Do the triangle. Here, comparing now what I had here, let's slide over here. If I treat this as a proportion now, it says I have 15 over 100. That was my R over 100. And now, this is to be my part at 9.5 over my whole, which is W. And so now when I cross multiply, it's 15W is equal to 9.5 times 100 over 15. Well, if I look at these two, another way of looking at that 0.15 is 15 over 100. Then I would invert and multiply and get exactly what I have here. Yeah. Same approach, different problem. And it gives you a nice way of comparing them. Now it's interesting, Sarah and I have talked about this a bit in terms of which of these methods is preferable. We have, right now, 3 different approaches we've taken. One was the triangle in Math 10. The other, if you'll remember, was using one of these formulas. Or we could have said that the rate is P over B, or we can say that if you want the base, it's equal to P over R. You could have memorized one of those formulas. You can use the triangle. You can set it up as an equation, or you can do it as a proportion. 4 different approaches, same problem. Now, of those, where do you want to put your hat? Thinking of what you're going to do in algebra, we call them mixture problems. So you start out with, just give you an example. If you are asked to do a salt solution, a saline solution, and you have available 2 bottles that are clinically pure. So you have 2 bottles, and one is at 20% and one is at 10%. And you want a mixture that's 15%. Well, you take the same amount at 20, you have at 10, put them together, and you have a 15% solution. But what happens if I wanted 18%? That becomes a mixture problem. And the form I'm going to use there is going to be more in terms of this kind of statement. That generally speaking, you're going to multiply a percent times a base, and you're going to use that in your mixture problems in algebra. If we look at pre-algebra, Math 20, as a part of a prerequisite to a business math course, an econ kind of background, where we've been talking about simple interest, we've talked about investments, and we've talked about the economic downturn. Then, if I'm looking at it that way, my guess is I'd probably be inclined to focus on the formula structure. If I'm talking about how you think and trying to encourage a level of thinking, this is a very different idea, a level of thinking that will contribute to your intellectual ability to do analytic thinking, then the proportion's a neat way of forcing that because it encourages proportional thought. And we're trying to take you out of that stress syndrome where you basically go into survival mode You quit thinking and run. Crawl under the desk, forget your name. This process in proportional thinking is very important. So this is a rather interesting transition chapter. It's part of every pre-algebra book. And the assumption is minimally that you go into an algebra, you're familiar with these three formulas up here. As part of a pre-algebra that you can convert to an equation and solve it, and then this process here is in a way building on our whole triangle concept, trying to decide what you don't know. Now let's go back to the document cam, because what happens here is you get some crazy numbers. I say crazy in the sense they are done with the idea of challenging you, but not necessarily benefiting you. If I stay just for a moment longer on that, Ernie, 102% of 88.5. I know why the 102% is there, but at the same time, 72% might have made more common sense to you. As we come off there, just looking at some of these numbers, number 19, at 16.9% of 2,450. Okay, 16.9%. That's like an APR on a credit card. So I can defend that to some extent. But when I get down to something, let's see if I can get another example here where perhaps a little more bizarre, and I understand the intent. I'm sorry, Ernie, come off there for a moment. When I move the camera, I didn't mean to have that go on the broadcast, but coming down here now, if I look at 461.25 is 10 1/4% of what number? That just looks more intimidating than what we just looked at. Or 28, where we have 110% of what number is 251.35. I'm not sure we're gaining a whole lot from the standpoint of what we're supposed to be doing in a problem where by doing it, we somehow get some insights as to what's happening in an algebra class. But let's look at one of those two just to demonstrate that it still fits into the same category. 461.25 is, then I have 10 1/4%, and then of what number? They take longer to write this way. But as we come off there, what are you going to do again? The equal sign. The what number is going to become your x. And you have 10.25%, which is 0.1025. And now the question is, did I have to do that? Well, no. I could have done it as a fraction and said this is 41/400. 4 times 10 plus 1, so 41/400. Does that gain you anything? My own reaction is no. You're still going to have to do what in solving it? You're going to have to divide both sides. Now, if we take it from the proportion idea that we're supposed to do, now not much is gained here. This certainly doesn't look very good any way I cut it. But if I do it as a proportion, it's R over 100, P over W. So I know my 10 1/4%, correct? So I have 10 1/4. And you look at that and say, as we bring it down just a bit, Ernie, wouldn't it be nice if what? If that were just 10. If it were 10, the problem would simplify enormously. Now, as I look at that, what is it that I have, P or W? If I'm taking 10% of something, the something would be my whole, and this is the part I have, correct? So I have the 461.25, and suddenly I sort of like that 100 down there, because when I cross multiply, the decimal is going to go 2 places to the right, and no decimal. I've got my W. Okay, so the cross product. You see where this is nice here? That will just move the decimal 2 places to the right. So I have 10.25 W equals 46125. So W is going to equal this rather large number, 46125 over what? 10.25. Now, if I don't like that decimal, I can do what Natalie was talking about. Natalie or Kim, I think it was, and I can do what? Multiply this by 100 and this by 100 and have an even bigger number in the top over 1,025. I don't care how you cut it. This problem, messy. The fun part was over here. The minute I got to there, cross-multiplied, it was no longer fun. Okay? And wasn't really at that point too much algebra. Kim?
Where you put point 10.25?
Yes.
Wouldn't it be 10.25?
But it was over 100. 10.25% means I have to divide by 100 then, and then that moves it 2 more places to the left. Remember, that's back to that 0.5% is 0.5%, which becomes 0.005. Same game. That's where you can get caught. The problems aren't any different. Some of them are nice, some of them are not nice. Any question on them? We're okay? Okay, yeah, well, that means I'm coming over here, though. This was 10 1/4 over 100. There's your 10 1/4%. Because I wrote that as a fraction, this could have been 10.25 over 100, which when I do that, I get 10.25 here. And then when I took the 100 times this, that moved the decimal over 2 places. Because again, that sort of cross product where you think of making this kind of cross and you're just multiplying across there. We okay? Let's go back to the document cam for a moment. I mean, that's like the 30th problem. And these are just doing the same thing. So it's a choice. You see a problem like this, what we just had in the document cam, and unless I tell you what technique to use, not clear. Okay, well, let's just move right along. Let's go to solving percent problems, which is 8.4, briefly. I just want to bring this into perspective. So solving percent problems. And, of course, this is the idea of portions. Now, as we come off there, what is going to be different about these problems than what we've been doing? And I think what you're going to find, this is like in the percent problems I gave you word problems. And it wasn't an equation. You didn't have the option to sit there and say, this is the part, this is the whole. It was more confusing. So, we come to problem 11, page 602. Now it says Wright earns 10% of total sales in what's called commission. Now, right now, if you are on commission only, this is not a good time in the United States to be on commission only. Okay, because if you're having no sales, you don't get any commission. So usually, as we come off there for a moment, just to put that in perspective, if you're doing sales, you have usually a base salary, which is enough to pay the house payment, pay the car payment, get food on the table, meet the necessities, but you aren't going to be putting stuff in the bank for your trip to the Bahamas. That comes from commissions. So it's base salary plus commission. So this is a case where now you're looking at the commissions. So you have 10% of total sales. And it tells you that he sells $31,106. I would have appreciated a comma in that. In merchandise over a 2-week period. What is his commission? Now, shortcut, by the way, if you're just doing this in your head, what's your answer? Be careful. 300 is not what I wanted to hear. $3,110.60. Move the decimal 1 place to your left. But coming off there for a moment, we'll get back to it. I know. No, it's 3,106. We would usually put a comma between the 3 and the 1. But my couple comments here first. You can do some of these in your head. I still want you to write out documentation. Second comment. Once we set it up, then it's a question of what you're going to be obligated to as a solution. And the obligation here is to try to use the proportions. Third comment. Some of these numbers are going to seem bizarre to you. But I've had to learn how to rethink my idea of big numbers. In the sense that one of my sons works as a, national sales for a company related to the computer industry. And when they look at contracts, they look at $1 million contracts. And so when you look at sales, if you get $1 million contract and it's say 1,340,000 so on, and you get 10% commission, your idea of a big number changes. My idea of a contract or your sales might be, okay, you have 3,000 sales for the week or the month. But if you have $3 million in sales for the month, it just doesn't rest well in my head because I don't deal with those kinds of numbers. So when you see 3,000, that isn't a big number comparatively speaking. But if we come back to that, then the question is, how do you set it up? So let's come back to the word problem again. 10%. Okay, that's your ratio, agreed, R over 100. So we have R over 100, and we have P over W. So as I look at that, I have 10 over 100, and that's to equal what? Well, my whole is what? My 3,106, and I want the part that you're going to get as we go to the board. There's the portion, what I call proportion. I'm not too keen on calling it a portion. It's a proportion. And now, you can cross multiply if you want. So you have 100p is equal to 10 times 3,106. So you, in essence, say you have 10 times 3,106 divided by 100. And of course, if you leave it as a fraction, you cancel here. And that's why you took 10 into this, moved the decimal one place to the left, and ended up with $310.60. Now, putting numbers into perspective. In the last 48 hours, there was another person indicted, I believe it was an indictment, on the Bernie Madoff scheme. And he was a hedge fund person who had basically, as part of what he was doing, got somebody to invest something like $2 billion into Bernie Madoff's scheme. Okay, so I get a commission, 10% of $2 billion. $10% of 2B in the newspapers. Billion. Okay, so yes, you could, but 2 billion is what? Okay, there's thousand, million, billion, and all I'm going to do is move the decimal what? One place to the left. So instead of getting 2 billion, this dude gets 200 million. 10% starting to sound pretty good, huh? So he gets 200 million and is now being accused of contributing to the Ponzi scheme, as it's called, for Bernie Madoff, and is, I think, in trouble. Okay? Easy money. Interesting comment. Leave that on the board. Something came out of NPR yesterday. Just to put this in perspective. One of the things that has been commented, that when you have $2 billion and you get $200 million in a 10% commission, it's the big money that I think bothers us. Now, I told you that if you sell my boat, that I want to sell it for $300, I'll give you 10% for the sale, and I give you $30, nobody gets upset. I'm happy. You sold my boat. I've got 270. You got 30. We're both happy. The person getting the boat's happy. And nothing's wrong. All we did is change the magnitude of the numbers. Now, Bernie Madoff gets $2 billion. The person making the transaction gets 10%, $200 million. It's like the $30. Yet we're bothered by what? The huge amounts of money that are transpiring here going in this transaction. And so there was an interesting comment that the more on the line, the bigger the error. So if you're getting a 10% commission and you sell my boat, you aren't stressed. But if you get $200 million because you make this transaction, you get stressed and your judgment gets flawed. And the people making the most money are doing the worst deals. The argument is because the stress of what they're doing basically corrupts their ability to analyze and come to correct answers. That was some research reported on NPR, I think it was yesterday morning. And an interesting comment here, to put it in perspective, I can give you a list of 10 numbers to add and ask you to sit down and do it, and no stress, and you tend to get the right answer. Now I put $1,000 in front of you and say, if you get them right, you get the 1,000. If not, you lose it. Or worse, I'll put $1,000 on the table if you want to play. If you get it right, I'll double the money. If not, you owe me 1,000. Now add the 10 numbers. Still want to play? And the idea is you get enough stress, what happens? We're back into grabbing the blanket, Linus's blanket, popping a thumb into our mouth, and say, I can't think. I can't do it. Same idea. So this is, again, arguing why in this big AIG mess, where people are getting bonuses of what? $1 million bonuses that they are making some really dumbass errors, the DAEs that we talk about, because of the stress of thinking I'm going to get $1 million in bonus, and all I can think about is the bonus and anything to get the bonus. Look, I could do with $1 million. Okay. Integrity? Nah, I want the $1 million. And that's been the argument for why AIG and other companies are, in a sense, responsible for some of the biggest errors because they aren't thinking well because of the pressure and stress provided by that large amount of money. That, I hope, puts things in some context in what we're talking about here. And again, 10%, keep in mind my boat. $300, you get 30 for selling it. Is anybody going to write the newspaper about the huge bonus you got? If Michael sells my boat for me, nobody's going to get upset. But if you get $300 million, oh yeah. What did you do to deserve $300 million? Well, the same thing you did to get the $30. There's just more money was involved. Okay, enough of the soapbox. Let's go to problem 16. It's got more lines in it, so it must be a little bit different. Okay, I know, I opened up a can of worms here. Okay, Michael, comment. Number 14. We'll come back to that. Let's go to number 16 for a moment, since I have it under the document cap. A writer earns 15% of the publishing company's net profit on the sale of her book. By the way, that's a pretty good royalty figure at 15%. Okay, so if the company sells 13,000 copies and makes a profit of $6 on each book, what is the writer's royalty? Okay, just because you write books does not mean you're going to make a lot of money. Trust me. One of the things I still have on my bulletin board is one of my royalty checks off one of the first books I wrote. $1.28. I did not cash it. I left it on the board to remind me that sometimes you don't do much in terms of what the figure is. So $1.28 royalty. And these days, if you write and you do desktop publishing and you try to cut some expenses there, your cost of your equipment and everything you do sometimes can be more than you'll make in 3 years of selling books if you sell them. And of course, the nightmare of any writer is to see them at Barnes & Noble for $2 a copy because they didn't sell. Okay. So we're back to number 16. 15%, as we go back to the problem, of the publishing company's net profit. So you sell 13,000 copies and you make a profit of $6 on each. And so the question is, what is the writer's royalty? Well, this doesn't fit nicely into taking the numbers and doing what? Saying this one's the percent, this is the part, this is the whole. Because what do you have to do in this problem before you even start? How much the company profited before you can get the 15% of it. So this is a case where you would have to do what? Take the 13,000 times the $6, which is $78,000 in profit. Then, if you want to set it up as a proportion, what would you have? What would be your proportion? Do you think of that for a moment? Okay, you're going to take 15 over 100. That's good. Okay, 15 over 100, and James is asking if P is the unknown, and that's correct. We have 78,000 as the whole, so as we come off there for a moment, Ernie, put this under the document cam, there would be my proportion. So the point being, there are occasionally what? Intermediate steps. Now, I think in some ways, as we come off there, I like some of the problems I did in the percent unit better than I like some of these. Okay? Well, you can work that problem out later. Now, I had a request from Michael to look at 14. Okay, this is a problem where I said base salary plus commission. This is one heck of a low base salary. You're getting 10% on total sales plus what? $5 per hour. $5 per hour isn't even what? Minimum wage. So you aren't going to get too much going on here, but let's see what we've got. We have 80 hours of work over 2 weeks, so that's 40-hour weeks, and has a total sales of $5,827. And you want the gross pay. Now from your percent problem, do the 80 hours and the $5 per hour have anything to do with it as a percent problem? Your answer should be no. Okay, the total sales is what you're interested in at the $5,827 because that's what you get as 10%. Now, you darn near can do this problem in your head to the extent that 10% of that is going to be $582.70 plus what? Plus your wage, which is $400. So you can say you have 400 plus 582, that's $982.70, and you've done nothing other than do it in your head. But the intent is, do it as a proportion. Now, my intent is not to have us fight those problems right now at the moment. Hopefully, there are a few of those that are a little bit better than what we were just doing. I guess if I jump all the way down to problem number 23, this is a little bit better. A company spends $245,000 on advertising. Now, this is, by the way, during the first quarter. If this represents 49% of the advertising budget, what is the budget for the year? What do you not know? P, W, or R? 23. Okay, I hear the whole. I heard W. I would agree. Because the $245,000 is a part of the total budget. And that represented 49%. That's the kind of problem we did in percent unit in Math 10. We come off there. And we would do it just as a proportion now to make it a little bit more interesting. Got it? Okay. Now, at this point, I'm not asking you to do any more than 8.1 and 8.2. 8.3 is like 8.2 with proportions. So tomorrow, I would like to answer questions on 8.2 and try, please, some of the problems on 8.3, just as a proportion so we can answer questions. Because Thursday's the exam. I don't intend to come back to 8.1, 2, or 3 after the exam. I'll go into 8.4 on Monday, spend some time in that. And I'd like to spend the bulk of our time tomorrow overview of what we have to do to get ready for the test. So if you can spend enough time tonight that you go ahead and work on 8.1, 8.2, and 8.3, particularly 8.2 and 8.3, and see if you have any questions. We can answer those tomorrow briefly, and then spend the remainder of the time talking about the test. And I need to make a correction from a statement I made yesterday about the test. The test, in my head, was thinking about when we went up to 3.1 and 3.2 as the first test. We've had 2 tests. So we went up to 4.4 in the last test. So this last section in Chapter 4, which is 4.5, then all of 5, all of 6, and all of 7, but I skipped the last section in 7. We did not do 7.6. So it's 4.5 through 7.5. So 4.5 through 7.5. And let me give you some insight of what I will be doing, and I'm not just sure what time frame I will do it because I haven't done it yet and need to spend some time in that. But I will be going ahead and writing up questions for the exam. And what I will do is look at the number of sections I have in a particular chapter. So here happens to be Chapter 5. So those are the first 5 sections there. There are a total of 8 of them. So I'll look at each section, as I come off there now, and I will pick a problem from it. What I think is a representative problem without being overly simple and not picking the hardest problem in the section. So if you want to know what I'm doing, you can do the same thing. You could look at that and say, okay. And you may say, well, wait a minute. I think there's 2 or 3 that might qualify. Okay, try each of them. But that means 8 problems from Chapter 5 minimally. Okay, I go to Chapter 6 on decimals. And I have 6 sections there. So potentially 6 more, so I'm up to 14. Then I come down to Chapter 7, and I have 5 there. That puts me at 19. And then 1 problem from Chapter 4-5 as we come off there, and I'm at 20 problems. No magic to it. Now be cautious in the following way, that if you look, and I'm just going to take a particular section here as a typical, I'm in Chapter 6, and I'm going to look at section 6.2, which is page 418. Because as I've shared with you, my intent is not particularly to do the simplest things that we've did in Math 10, but I'm looking at page, this was section 6.2, I think I said. In 6.2, what I'm trying to do is look at the problems here on 6.2. So I'm looking at this at the beginning of the problems. Okay, so I'm on page 424, and I'm trying to hit a point here in the few minutes before we have to stop. You're not going to get this for a test question. Okay? If that's what you think is an intermediate level difficulty, I am sorry. You will not get one of those from that section. Okay? Now, one might argue that things are getting a little more interesting down here at 27, because we have as many negatives in one problem as you can possibly put. Now, that's getting close to a possibility, but I might be more inclined, as an intermediate level difficulty coming off there, to do something like 32, which is at the bottom of the screen where I have a 4.2 m to the second plus an m cubed minus a 9m, where you have to do what? Combine like terms. Okay, and then simplifying. Now, I could argue that that in some ways is harder than maybe number 44. 44 is not a difficult problem, right? but it involves subtraction or addition with decimals. So if I look at that problem and I'm saying out of 6-2, and you're playing the same game I am, it's not going to be from the first probably 20 problems, because those are basically math 10 with a few minus signs thrown in. It's probably going to be combining like terms with decimals involved or solving a simple equation with decimals. Does that give you a better perspective of what I mean by intermediate difficulty level? Don't expect me to test you on things we did in Math 10. They will involve some part of algebra. So I would encourage you, in addition to what you're doing tonight, look at each section, and it only might take a minute just to see what you think is a typical problem. And you look at that, you ask yourself, could I do it? And write down your selection for 20 problems. Then, tomorrow when we ask about what we're covering, you could look at it and say, I looked at this and I don't have an idea in the world what I do, and we can prepare for the test better that way. Ernie, as we go back.